this talk was the result of a conversation that began partly with Richard about a year ago.
Oh, yeah. Wireless mic, please.
Where's that? There we go. Began with a talk. Nope, it will be late. A talk that began by discussing a few things with Richard, but also having worked on it for over a couple of years with Palmer. And in fact, it's going to really be two talks combined into one. One's going to be a historical look back at the early years of Texas Instruments against HP. That began with Richard, because I had some ideas about how to try to visualize that, how to think through it. And then we're going to look at some quirks and techniques from Texas Instruments calculators, primarily because most of us are very unaware of them. And if we don't have it videoed and put on YouTube or something like that, it will totally disappear from the face of the earth.
I know that.
But I want to dedicate this talk to Palmer Hansen, who was here in this room 3 years ago, last time we were here. Roger reenacted the great calendar race in the back.
And you know who's on the other side of his hand.
Sorry I had to cut you off, Roger.
That's okay. That's
the next year's talk I'll dedicate to you. Is that right?
That's okay.
But
hopefully not posthumously.
I didn't mean it that way. Oh, no.
You've gone from bad to worse.
Hey, and again, the day I'm having, please, Roger, be very careful over the next year.
Yeah, no, I won't touch anything.
Don't touch anything. But the last communication I had with Palmer, I spent about 45 minutes on the phone with him about this talk in early March. And he had told me that he was just getting really tired because all he ever seemed to do was be at dialysis. And that's why he was getting up in the day, was to go to dialysis. And I asked him for a few things, and I got an envelope in the mail, and then about a week later I heard he had passed away. So this is to Palmer, who kept alive the joy of the TIs. Now, why look at TIs? Well, there's two maxims. You need to, from the philosophy, know thyself, but also from, who is it, Sun Tzu, know your enemy, know your adversary. Right, so both of those. I think we know ourselves pretty well as HP people, but I don't think we remember sometimes a little bit more of the adversary. So I brought in an expert to help us visualize that right here. So I want you to just make sure it's going to be okay here. Good. It's nice and loud. If it's too loud, sorry. But let's turn the light off for this over here. We'll just keep it like this. Here we go. Listen up to it. He is certainly the expert.
Underestimate the power of the dark side.
So we need to understand the dark side so we know what kind of power the dark side really has or had in this case. So in this discussion of who is better, TI or HP, one thing is absolutely off limits. RPN versus algebraic, for my point of view here, is over there. That is not to be brought up. We're simply talking about features and price.
Equal sign.
Nope. No equal sign. No enter button. Okay, so that's over there. You and I all like RPN, I suspect, better, but that's not the point. The point is, what features did it offer, and was it a compelling price point?
And the quality, too.
Double width.
Some quality. I'll talk about that a little bit. Okay, so here we go. We'll leave Vader behind. To start it off first, the HP 35, somewhere here in early 1972, more or less, $395, and it had trigs, logs, and of course RPN. So HP has the market all to itself. There is no real competitor, of course, in the handheld market. Who is ahead? HP. Now notice, February 72. Okay. And of course, their little, we could leave that up there for a while if you like. But okay, never mind.
It's beautiful.
A full 9 months later, TI can barely manage a square root. Okay, so it has square root, reciprocal, and x squared with the SR10. Lovely wedge shape. Okay, you could.
But the buttons are bigger.
Ladies could put these on and wear them and be very stylish. 9 months later, who is ahead? HP. I mean, hands down.
The scientific notation also.
Scientific notation, that is true. And it does have a clear display key, which comes down. But you get the point, right? Really no comparison.
Is that equals key bigger than any of the others?
It's a double-sided equal key.
Zero.
It is truly less than half the price, but for what, right? So
What does that clear display thing?
it's a clear entry, it's clear what you just get. All right.
Just like
What is that? 6-7 months later, the HP 45 comes out at the original price point of the HP 35 and added a lot of other stuff. Basic stats, conversion, factorials, and 9 memories. TI still only has the SR10. So no competition whatsoever, no discussion. HP is still tremendously ahead, and there is now 4 months later.
Oh my, yawn.
Right? Now again, that is a year and 7 months after the HP 35 came out. TI has managed to make the buttons a little smaller. Okay? Who is ahead? It had Pi. It's not even in the ball game. TI's not even in the ball game in terms of making a machine. Now,
No memory.
7 months later, January the 15th, 1974. This is the first date that TI actually, in my opinion, is in the ball game with the introduction of the SR50. I remember seeing this right before summer began in the 7th grade. Rich kids in the cafeteria had these things, and I had no idea what it was. Okay, but I remember the light sky blue buttons, the orange button in the corner. Look at it from a feature perspective, and we're going to put the calculators up side by side in a minute. It is at 40% of the cost of the 45. But it has hyperbolics, it has a direct root calculation. I know you can take reciprocal y to the x, but that was the selling point they would have. You don't have to do that. No questions.
I'm just saying that
I'm just kidding.
early
saw my
machines that
first-
had hyperbolics.
It is. It's got this hyperbolic key. Rich is totally right. Hyperbolic key. It had grads, of course. That was very useful for everyone. Mean, standard deviation, 5 conversions, and some percents. It also had factorial on it as well. In my opinion, at this point, on a price function standpoint, I really think TI has the lead with the SR50 in a pre-programmed calculator. Here you go with the big ones. I mean, look, it has some conversions that this doesn't have. It doesn't have the conversions. It doesn't have polar rectangular. There's still a few more features, but for a large amount more money. Now, if you're dealing with polar rectangular all day, this is your baby. But this is an incredible value for 40% of the cost of the HP 45.
And that still had only one memory, like the 30.
This one still has only one memory. Right? But again, it's a matter of value and function. And so if you're looking at it, unless you're just very, very rich, the scale certainly, they're finally in the game at least, right? And in my opinion, which is all it's worth, they, in fact, I would suggest it's tilting more toward them. January 15th, I think it was, 1974. What happens a few days later? The HP 65. So TI, you can imagine TI management. Yes, we're finally in the game. What? When the 65 comes out. It's very expensive, very, very expensive, but it's certainly a game changer. Now, eventually, we will split up and really only focus on the pre-programmed for a while because it takes TI, again, a long time to catch up with the program stuff. HP comes out with the HP 55, and at the same date, which is almost a year later, January 75. It's a very quiet year. Very quiet year in many ways. I'm not introducing every single one that pops up. But the SR51 at 225 compared to not the 55 and the 65, but the 45, which is still the scientific model, finally added a lot more stuff. This is a really powerful puppy. It would do the variance, mean, standard deviations. It would do linear regression and estimation. It had permutations. It had random numbers. It had, it's got a lot of stuff, as well as 20 conversions on the keyboard and inverses. So it added a lot at 225 for a cost. This is a really tough model to get because it was only made for 5 months before they updated the industrial design. And most of the time when you find it, this silver area is very worn off. So if you find one with that silver area that's in very good shape, it's going to be worth a few pennies. So you can keep your eyes open for that if that's the kind of thing you like to look at.
Jane, it was replaced with the A, right?
It was replaced with the SR51A, which shows up very shortly. So here's your 45 and 51. And I really think this has 3 memories, this still has 9. But, you know, up there in the $300-something range and just above 200, it's hard to really say, other than RPN, which is not on the table, right?
And build quality.
SR51 is very well made. These don't fail. It's the 52 that has its circuit board is wide open to the world that tends to fail. I don't find hardly any of these that don't work.
Don't have key mounts on those?
They have domes. They have it's very, very nice. I got one up here, in fact, for people to play with after the talk. Here's the 55. The 55 has the conversions, more or less, that has, and a few other things. Of course, they're programmable, but A month later, HP returns serve with the HP 21, which is essentially the HP 35 at a third the price. So it's maybe TI, but this is $100 more than the 21. It's got more features than the 21, right? Another close-up here. More features than the 21. But, you know, you can defend going with this if you're wanting a scientific and not spending a lot of money.
You want quality.
And quality. Again, don't diss this guy on quality. I suggest don't assume just because that's a TI it's really poorly made. That's very very well made in my opinion compared to some of the models.
Quick question, 51A, 51-2.
51-2 stinks. All right, 51A, pretty good shape too, although the circuit board is exposed in the 51A. A few months later, you have some design changes from TI. It's a facelift, no functional upgrade. You have the SR50A, which is the lovely light blue keys gone into a business-oriented design, perhaps. Got a couple of views of that. And then the SR51A. This was the one I wanted for Christmas, and I didn't get it, so I had to buy it later myself. But with these guys, I still think potentially, you know, that they are ahead of HP in the value function of what you can do by pushing the keys comparison. Here you go again. You can see the SR50, which has more features than the 21 did, which is about the same price at this time too, the 50A. And the 51A over there just loaded with stuff. I remember a science teacher challenged us, when you hit the Sigma Plus button, it increments the display by 1, 2, 3, 4. Said, over the summer, I want you guys to try to punch 1 million. After 10 or 20,000, some of us gave up.
Doesn't say much.
It took that long for me to give up.
You couldn't come up with a challenge that was actually educational?
No, it was just to say, quit playing with your calculator, perhaps.
Sounds how big it means.
On August the 1st, 1975, HP introduced the HP 25. Strangely enough, TI introduced the SR16-2. We haven't mentioned the SR16. It was a wedge-shaped device that had the same features as that 16-2, but the 16-2 was in a more, if you can believe it, sleek form factor. But it had logs, it had some other functions, but no trigonometry. That's what I got for Christmas. Okay, and all my friends had trigonometry, and I didn't. I know my parents. I'm sorry, Mom and Dad. I know they knew I was disappointed, but that was $50 compared to $170 or something. And
what are you ever going to need trigonometry for?
what am I going to do? I know, that's right.
And so you became a business major.
So I went to business, yes. What could have been, what might have been. I do have one of these up here. I keep it so I can remember disappointment. I love you, Mom and Dad. Really, don't watch this. And then, of course, the HP 25. A few months later, TI finally enters the programmable market with the SR52. It is attachable to a printer, of course. At this time, you've got the 25, the 55, and the 25. Those are your three programmables on the HP side. I would say HP is ahead, but the TI compared to the 65 is starting to push it a bit. It has 20 directly addressable memories. You can actually string 50 memories together that in a program. You can loop through those because it had indirect addressing. You got 9 over here that are really usable most of the time. 100 steps, no line numbers, right? 224, but recall 02 takes 3 of those steps. Writing a matrix program on that thing is nasty. And there you go with those. Indirect addressing, several different error tests. Don't diss it too badly. It's horrible from a component perspective. I don't know anyone that has one of these that the card reader still works. I wish I had one, but the card reader still works.
What's the time span between the introduction to the 65 and the 52?
74 January, and what we say on the 55, I mean the 52 here, year 8 months. A year 8 months. So this, right, they finally come out with it thinking we've got something in the ball game. Of course, we know what's coming next from HP. Yes, sir.
The card readers don't work because of, they don't read the cards?
They have very bad card reader motors.
Oh yeah, they have bad timing.
They have mushy.
Timing, and sometimes it just won't even turn on.
on
It won't even turn on.
But the wheels got mushy too.
The wheels, yes, but I mean, it's a nasty mechanism. It's a real nasty mechanism. Here's your killer for this, right? The next two. TI comes out with a cheaper programmable, the SR56, 100 steps, no constant memory. That's the first programmable I remember playing with when we were in the auditorium. Instead of watching whatever the educational movie was about geese or who knows what, we were trying to write infinite loop programs on this thing, figure out what was going on. TI had something now finally that masses could afford if they wanted it, and they weren't thinking of HP. This one, though, of course, I still remember seeing this and my jaw just falling open with the feature set it had for $25. TI finally puts a stake in the ground saying, take that. From a pre-programmed perspective, you really can't recover from that from a price feature comparison at $25. Yes, sir?
Just to point out, the TI-30 is still made in a somewhat more advanced edition, and in fact, I'm studying for the actuary exam. That is the only calculator permitted for the actuary exams.
It has gone through, I don't know how many different revisions,
They're
but
still
a lot.
around.
But it's still $25.
So, probably cheaper than that. So, here's the 56 compared to the 25. That really is your comparable machine. 100 steps versus 49. Merged versus not. It had a pause function, which was nice, but if you held the key down, the divide key down when the program's running, it would keep running and pause every step, kind of an interactive trace. You could see what it was doing. That was really nice. You could do it that way. The TI-30, sine, trig functions, it's a great little machine for $25. Yes, and I do say yuck, the TI-30. I really believe by now that TI is essentially ahead on any of the pre-programmed models. At this point, HP obviously is running toward programmability and leaving behind the rapidly price-declining pre-programmed, which took TI a little while to figure out. Perhaps the lead for programmability remained until the TI-59 or 58C. That's a bit of a heresy, but the 59 offered a lot of capability if it would work. Okay? I really liked the 58C because I didn't want to lose power and lose my program. And with the 58C, at least, it kept the material in there. I had bought a 58C until I saw the ad in the Wall Street Journal announcing the HP 41. Fortunately, I was within my 30-day return window, so back it went. It took me a while to get the 41, but I wasn't holding on. That's what changed me to finally be an HP person. Okay, now let's get on to some quirks and talk about fast mode. Joe, obviously, and other people really love punching 15 buttons at the same time just to see what happens. And TI had similar people on the other side for that. TI users found unannounced features and things that generated unexpected results. For example, this is bizarre. On the SR52, pressing second read and then simultaneously pressing B, inverse, sine, store, enter exponent, 4, and 0 would turn on the card reader mode. How many times did you push buttons until you found that? And why? Why do you want to do this? Don't know. I'm really not making that up, but Joe, I do think this is...
You just made that up.
Joe, you're an amateur. You're an amateur. For a more useful example, the SR52 ended up having two fully usable memories that the manual did not mention that TI later started touting. You could do store 98 and store 99, and they were just as useful as 0 through 20. They weren't clearable by the clear memory command, so you had two extra memories. Users used those to be able to write programs to copy data memories to cards, which was not built into it at first.
They also had another 60 that you could store, but you couldn't recall.
There were memories where you could hit store and put a value into program memory. So it's an early version of bug 2. Store 72 would store whatever the displayed value into program memory and make modifications to it. But these two are very useful, so it's always good to know about those. The TI-58-59 had quirks as well. You could get access to the hierarchical stack registers. 1 plus 2 times, the 1's floating around somewhere. You could actually get to that with a quirk that TI eventually acknowledged. This is interesting, of course the 58-59 had plug-in ROM modules before the 41. The owner's manual said call a subroutine with a label. This module, this program started label B or label D or whatever, something like that, right? But it turns out that you could actually put in after the module specification in the program, you could start the subroutine at any step. The PPC-ROM was the XE routine, XROM entry. 58-59 had that for a couple of years before the HP 41 synthetic programming gave that same ability. The ability to use the decrement and skip on 0 on any register. It was supposed to be only on one register, but it turned out, or I think 1 on that one. You could enter some value like this, DSZ9 store 34, and then come in and delete that step and delete that step, and the DSZ would work on memory 34. So you could create synthetic programming by just deleting intermediate values of the key codes and see if it worked. And so they did that stuff. Card reading under program control, think merge. Okay, they found that would work. Additional labels you couldn't key directly. You really can't key label 82. 82 is a key code position down here, something like that. But again, you could put store 82 to get the 82 in memory and then go back and delete the store and put in the label key code and it would work. So a lot of the tricks had those kind of features on them. Go to or go sub to the middle of a merged instruction. The key code 4238 is store memory 38. Okay, TI speak. Store 38. But if you have a go to the step holding the 38, that's the sign instruction. And so it would jump in the middle of a code of store in the memory 38. Instead of storing something, it would actually execute the 38 as a sign instruction. So you had to be real careful about where you sent your destinations. Weird stuff with that kind of thing. Whoops. High-resolution graphics were also created. This was after 1980. This is about 1981-82. They found that if you interrupted the print head movement, it would only print a few dots of a character. And then it would stop. And those few dots, they found they could string together line after line to do all sorts of interesting, to them and to me, graphics. For example, this is the usual print table. And as you can see, if you print that 8, but you only get a little piece of it, you get this little top thing, you get this line, you get 2 little dots here, and different pieces of the character, right? They were able to put those together to print something like that. Think about the multiple, the high-resolution plotting that was on the HP41. So that's pretty incredible right here. And it took forever because you had to key in all these different codes. You had to figure out, I need 2 dots over here. What? But that's pretty.
Guy that came up with the 6 fingers.
No, Joe was tired that day. All right, but high-resolution plotting, they really use this to great advantage in many, many ways. Fast mode. This is TI's statement in their PPX exchange when they first made the acknowledgement that this fast mode on the 5859 existed. Due to algorithm requirements, internal operations are normally executed in scientific notation. In order to format the results for the trace and single-step output properly, programs run in main memory convert after every step back to floating point, so that it would show it if you're doing trace or single stepping correctly. As those functions, the trace and the single step, did not work when they were running in a library program, in a module, it didn't do the conversion back and forth. So what they noticed is if you're running a program in a module, it was a whole lot faster than if you downloaded it into main memory. This was why. So what they found out was they were able to trick the processor in the 5859 to think it was in a module, and so it would not do that conversion. And they were able to speed things up by 50-60% in some cases. That was fast mode. That is how Palmer Hansen nearly beat Roger in the great calendar race. It's because he had his program in fast mode, spitting it out until Roger put it to rest once for all. Thank you, Roger. The earliest fast mode, this is, I hope you're not putting everybody to sleep. My apologies. The earliest fast mode procedure, this is bizarre, required the user to run a program which would put the machine into fast mode, but look, would also completely wipe program memory. So the machine's in fast mode, but then you have to load your fast mode program. Now, that meant under a Pro card, but a machine that had a card reader, it was very unreliable. You had to loop until you got it all working like that. This was called the load and go, okay? Or the load very slow, right? Because it was in fast mode, but it would take forever sometimes. Not particularly user-friendly with card reader problems. The procedure to start fast mode, really strangely here, was second program 2 in the master library. It would hit program 2, and it started subroutine at step 239. Okay, 239. So it's jumping in the module, executing a step. Why step 239? By the way, you had to have a 9 after this. It didn't do anything, but you had to have a 9 there. So here's the steps in rows 237 to 242 in the second program of the master library. It has, first of all, key code 29 here at this. CP is to clear the test register. It clears the test register so you can do comparison against 0. It then tested, is x equal to 0? And then said, if true, go to step 0331, transfer. If x is 0, go to step 331, and then it continued on. Okay? However, if you jump in here to step 239, it executes this step. Remember jumping in the middle of a merged key code? Key code 31 is the key code for learn, to put the program into program mode. And the 5859 freaked. It had no idea what to do with it. And it managed somehow or other to trick the machine into getting into fast mode. Palmer Hansen said this: the calculator logic seems to get confused by the code 31, read from the library module, and fast mode somehow results. That's all you're going to get. Okay? A code 31 in user memory, if you try that on your own in a user program, simply stops program execution and displays the program step. It hits learn on the keyboard. But in a library module, if you could find a 31, you had it made, because you could trick it into fast mode. And that came from, again, the PPX Exchange article that Palmer wrote. He was the one that wrote the article which said this to the world. Once this program was won, program memory was cleared. You had to enter the program either by hand or card, and then it was run while the machine was still hopefully powered in fast mode. Not very user-friendly. Actually, it was a really big pain. Fast mode was not very widespread given the trouble using it, and it had a whole lot of restrictions, things you couldn't do in fast mode, such as if you have a reset instruction, which goes back to the first program step, the calculator crashes. It was used. It was like go-to top of memory, right? Flags were set based on whatever program steps were in 11 through 15. Be careful what you have in steps 11 through 15 because once running, you can't stop the program from the keyboard. You got to turn it off if you get some kind of a bad program, which again would wipe your memory and start over. You could not use subroutines in fast mode. All transfers addresses had to be absolute jumps to step numbers, no labels. So pretty big set of restrictions. But you were getting twice the speed, and they were trying to beat the HP people. So it was very, very important to them. And not all instructions ran fast. If you had trig functions, those were running at regular speed, so it was not running fast. Patrick Acosta, another name very highly famed in the TI history, user history, developed a much better procedure, this is really strange, whereby the calculator entered fast mode if at the end of a memory partition, you could have 239 steps, 320, 480, you get to step 479, step 319. The very last step of the memory partition, no step beyond it, the last steps were a set flag, indirect, and then a hex code. I'll talk about that in a minute. It would jump back somewhere previously in the program and start running fast. So you didn't have to wipe the memory. You could actually have this on a 58C, and you could run the program all the time. This was a set flag indirect instruction, but the H17 was a hex code inserted bizarrely. Joe would have loved this. Here's how you would insert a different hex code. 9 second op 17, second program 12, subroutine 444 run stop, second polar to rectangular learn, second insert learn clear reset. That would leave a hex code stored in a program.
That's so obvious.
Okay? But once you had it in there at the end of program memory, you could have a program that would enter fast mode that you could save to a card and not have to clear memory and rekey it and all that kind of stuff.
That's obvious.
So I was asking, Joe, where were you? Where were you? Later explorations determined actually that you didn't need the hex code at all. All this wasted effort. Okay? All this wasted effort. You could simply have a set flag instruction at the very end of program memory and essentially key a couple of things while the display's flashing, and then it would kick off. That's what I'm going to show you in a demonstration here in a moment. This approach was used in the sample Factorial program in the handouts. There's a big PDF of a lot of the documentation of fast mode and other quirks on the thumb drive. And the first page of it includes a fast mode Factorial program. The TI-5859 did not have a Factorial key. It just computes not the exact Factorial, the approximate Factorial, okay, and does it in fast mode at about twice the speed. So it's still 30 or 40 seconds for a 69 Factorial, as opposed to a minute. The handouts conclude a few things, right? There's an article on quirks. You have Pastic Acosta's original article on fast mode, an article by Palmer. So he certainly was one of us, even if he had a bit on the dark side. Another article by Dejan Ristanovic. He's the one that runs TI59.com, the website, where he foolishly, sorry, Dejan, calls the TI59 the best calculator ever made. There's an exact fast mode program showing, for a factorial program, 34 factorial in a minute, 21 seconds, and 100 factorial in 10 and a half minutes. I have a whole book of exact extended precision programs in fast mode that I had permission for a little while to distribute this until the author pulled it back. I still don't know why. But if you want to get exact factorials up to 442, I got the program for you. If you want one to go up to 610 exact factorial, I can do that. E to 980 or 1300 places or 870. Pi to 1188 places or 1287, but you'll need to have a chair and a pillow because that takes 13 days to run in fast mode. Extended precision natural log, extended precision roots, square roots up to 155 places, and a different one that computes square roots up to 400 places, all in fast mode for your perusal browsing, but I can't give it to you because I don't have permission. So all this, some of this stuff's in here, right? Again, just look through it sometime if you have any remote interest in just seeing what the other side was up to. You need to know your competitor. Pages 9 through 10 have an exact factorial fast mode program. I think I mentioned that. I don't know why that's up there. The example program simply computes a real factorial. 69 takes 31 seconds in fast mode, but 52 seconds in regular mode. Here's the code. I want to show it to you. This is the end of a memory partition. You see this set flag instruction right here at step 319? That's where it's going to kick it off. To start it, label A, you clear the T register, and then you compute the tangent of 45 degrees. The value computed is 1.0000001, but it's got that 1, it's kind of off the display. You then square it. When you square it, you have a 2 in the 12th decimal position. Very important. Turns out, whatever value is in the 12th or 13th decimal position determines where it comes back and starts executing your fast mode program. The 2 right here will kick it off at step 001. That's what you want when you want a program to start over. And then set flag at the end, strangely enough, it blinks when that hits that instruction at the end of the partition. You hit 7 and then the inner exponent key and it's off to the races. It's actually executing your program, starting back wherever it was told to start. And then the rest of it, it comes back here and does clear, stores 69 into 0 and 1, and then you got the loop, right? Recall 1 minus 1, then you store it back, so you're decrementing. You can't use looping either. You got to do looping manually. It says, hey, is it equal to 0? Am I over? If so, otherwise, multiply it by what's in 0. Start accumulating a factorial and loop again. When it ends, it shows a negative 0 in the display. That's the way it signals that it ended, and then you recall the memory to see the factorial. The program, as I say, takes about a minute to run. Let me do that right here. All right, do you see it flashing? Everybody see it flashing? It's flashing a 1 at me right now.
Yep.
Okay. Okay. I'm going to press 7 and EE. It's not flashing anymore. There's no 1. So it took my input and it's actually computing the factorial of 69 right now. By the way, this is a 58C. If I keep up with a 59, this is the only one you want. It's still thinking. Anybody want to pull out their calculator and calculate 69 factorial? You'll be done before this will. It's still thinking. Still thinking. Did you hear the one about the 2 auto repairmen? No. Still thinking.
I guess one did tires and one did
Power steering.
Oh, hey, it shows negative 0. So that was fast mode. When I hit recall 01, recall 00 rather, there is the usual value for 69 factorial, 1.7 something times 10 to the 98th. Okay? If I want to do it not in fast mode, yes, we are a glutton for punishment.
So all that time it was blank, it was actually doing the...
It was doing the calculations. The screen displays a little C in the corner that flickers that lets you know it's running. So when I reset it and run, all right, it's now computing it. We'll just set it here. You want to hold that in front of the camera? It is, what did I say back here? 31 seconds compared to 52 seconds.
Okay.
So it's 40 seconds faster, 20 seconds faster, so it's what, 40%, something like that? Makes a big difference if you're talking about 13 days.
Oh, yeah.
Okay, and it's still computing there. So this program's on the front page of your sheet. What I would like to do is to encourage you, even today, know our competitor. Know our competitor. Because all this stuff is somewhat fun anyway. I mean, it's kind of fun to have to mess with this stuff. I mean, we're still talking about bike jumpers today, 30 years after the 41 was out. Know our competitor. And I also wanted to give honor to Palmer, who was the great nemesis of our beloved leader. I'm kidding. He was a good friend of yours, I know. He's a great man. I'm so glad again that he got to come. Any questions on the old TI stuff? Anybody want to dispute my rankings of who's ahead at any point, stuff like that?
Is there a group like this
No, it's
that
spun off
does
of this
TI
group.
stuff?
Recall
They spun
00.
off of this group.
But are they still meeting to this day talking about this kind of stuff?
No. There was a group that topped out at about 1,000 people, 1,000 members, somewhere in the mid to late 70s.
No, I know back then, but today.
None today.
Still, no?
None today that I know of.
The equivalent today is the TI groups that do programming, a lot of focus on games, but writing OS shells and breaking over assembly.
There's no kind of backward looking.
Not physical
No.
meeting groups, it's discussion boards and things like that.
Yeah, yeah.
There's a TI
lot of those
email
guys do
list.
this.
It's those newfangled youngins wanting to play games.
This is probably sacrilege, but has any thought been given to make game programming easier on the Prime in order to appeal to the younger audience?
It's already easy.
Okay.
Not doing
All
it
right.
much.
Well,
Are you done?
I'm done. Thank you so much for the.